Hi there. Welcome to week 3 of college algebra. Can't believe we've gotten this far, but I hope the learning guides have been helping you as you navigating week by week. Here in week 3, I've got 5 different parts of the learning guide. So 5 different videos. I'll be sure to link all of them down in the description so that you can have them if you need them. Also, if you would like a copy of the learning guide, I will have a link in the description as well that you can download it from. So you can take excellent notes. The whole idea is that while you're watching me work problems, you are taking notes that are going to help you be successful with the assignments in college algebra. So, just a reminder also, don't forget to like and subscribe. That way, you get a notification every time a new video is posted that could help you with your concepts as well. One last thing, each page of the learning guide has the click here to learn how to work these examples. So this video only focuses on the examples that you see on this page. We will have another video for the examples on the following page. Let's get started. This video is going to focus on solving quadratic equations and rational equations. So we look at problem number 1 and we see we have 2 parentheses that are being multiplied together to give me 0. When that happens, we know that we can take each parentheses and set it equal to 0. Because in order for them to multiply to give me 0, one of them has to be 0. Now we get to solve each of the equations separately. So x plus 3, we'll subtract 3 from both sides to get that x equals -3. For 3x minus 4, we'll add 4 to both sides and then divide by 3. So we get that x is either -3 or x equals 4/3. And so we have 2 solutions here. It's totally okay. And there they are. Now, if you've seen any of my videos, you know I like to use color in math, so makes it a little bit fun. Look at the second one here. We're going to have to factor it for ourselves, this left-hand side. So we ask ourselves, well, first of all, let's recognize what's missing here. The x term is missing. And so we ask ourselves, what 2 numbers will multiply to give me -81, but add to give me 0? Well, we're going to put those in parentheses. So again, what 2 numbers multiply to give me -81, but add to give me 0? That has to be +9 and -9. This is called a difference of 2 squares. A difference of 2 squares. And that's because x squared is a perfect square and 81 is a perfect square as well. Now let's take each of these parentheses and set them equal to 0. And we solve. We'll subtract 9 from both sides and we'll add 9 on both sides. So I've got that x equals -9 or x equals 9. So realize problem number 2 here just had one extra step from what we had done in problem number 1. In problem 1, they had already factored for us. In problem number 2, we had to factor for ourselves. Now, looking at problem 3 here, we're going to then go on to rational equations. You may be thinking, well, what does rational mean? That simply means in math context that it's a fraction. So you have an equation that has fractions in it. I'm going to try to make this as simple as possible for you because if you remember back from elementary days with fractions, we always talk about common denominators. And we are going to do that here too. We're going to think about common denominators, but we're not going to actually make them. So when I think about common denominators here, what I'm looking for is the denominator that would be divided by each of these. I want to say that right. So here's my trick, friends. When you see two different denominators, I'm actually going to clear the denominator. Let me show you what I mean. Okay, I'm going to set it up here. Here's my original problem. Okay, now I'm going to go through here and I'm going to multiply by both denominators. And I'm going to multiply every term by both denominators. Now I'm going to be real careful to put it in parentheses so that I can see the multiplication. All right, now watch what happens because this is the key part that you don't want to miss. You see how this has an x minus 1 and this has an x minus 1? Those cancel. And we're left with x minus 2 times 6. Fraction gone. It's the whole purpose of what we did there. Okay, let's see what happens here. The x minus 2's cancel. And that leaves me with x minus 1 times 2x. Now over here on the right, nothing cancels. So we've got to leave them. Okay, but realize what we did there. We got rid of the fractions. It's going to make this a whole lot easier. Now, use your distributive property. Okay, when you multiply, 6 times x gives you 6x. 6 times 2 gives you 12. Now we'll multiply by 2x. 2x times x gives you 2x squared. 2x times 1 gives you 2x. Then we've got to multiply over here. Now I'm going to leave the 2 in front. And I'm going to use the box method to multiply those two parentheses. And I brought another piece of paper to help with that. So I'm just going to do it over here on the side because I didn't want to take up so much space. So I'm doing x minus 1 and x minus 2. So that leaves me with x times x is x squared. X times negative 1 is negative x. Negative 2 times x is negative 2x. Negative 2 times negative 1 is 2. So look at the 2 in the middle that you can combine. So that's going to give me x squared minus x minus 2x is minus 3x plus 2. And so that's what the box helps us with. Now let's go ahead and combine some like terms. I like this 2x squared to come first. Then I've got 6x minus 2x is 4x minus 12. Then I'm going to distribute the 2. So 2 times x squared is 2x squared. 2 times minus 3 is minus 6x. And 2 times 2 is 4. Now, let's get all of our x's to the left, and we'll get all of our numbers to the right. So I'm going to subtract 2x squared. You'll notice that when I do that, I line it up underneath the x squared term. I'm going to add 6x, and I line it up underneath the 4x. Now I'm moving the 12, so I'm going to add 12 to both sides. Let's see what happens. 2x squareds cancel. 4x plus 6x is 10x. Minus 12 plus 12 cancels. So that equals 2x squared minus 2x squared cancels. Minus 6x plus 6x cancels. And 4 plus 12 gives me 16. So you see how I moved all of the x's to one side, all of the numbers to the other side. And now I'm going to divide by 10 on both sides so that I get x is 1.6. Now, friends, what I did there was all geared around the point that I wanted to get rid of the fractions so that I did not have to deal with those anymore. That's why I multiplied by those denominators and then proceeded to solve. All right, our last example for this part of week 3 notes is we're going to be rationalizing the denominator. And I left you a good example up here of how to rationalize the denominator. Something you have to know. The whole goal of rationalizing the denominator is to get the denominator to not have a square root in it. Okay? So we use something called the conjugate. This is called the conjugate. So we take our expression and we're going to multiply by the conjugate. Now, the conjugate is the entire denominator because it has a square root, except we change the sign. Since this is a plus, we change it to a minus. And just like the example that I have there, we're definitely going to put those in parentheses because I want to make sure that we distribute. Okay, so first we'll multiply by the 7. That's 7 times 3 is 21 minus 7 times square root of 2. Just a reminder, you can't multiply a number outside of the square root times a number inside of the square root. Then we'll do the box again for the bottom. So I'm going to do 3 plus the square root of 2, 3 minus the square root of 2. 3 times 3 is 9. 3 times square root of 2 is 3 square root of 2. 3 times negative square root of 2 is negative 3 square root of 2. And square root of 2 times negative square root of 2 is negative square root of 4 or negative 2. So I want you to see what we have on the bottom. These two cancel out, and these two give you 7. So use your box to organize your multiplication there. And the last step here, I want you to see that you can split this into 2 fractions. They both get a 7 in the denominator. And I would do that because it makes it easier to simplify. Now remember, the whole goal of our rationalizing the denominator was to be able to get the square root out of the denominator. And we have here. So I hope that helps with getting started with week 3. I'm going to link the remaining videos for this week's learning guide. Please feel free to leave me a comment if there's a question you have or you're not sure about. And don't forget to like and subscribe. That way you get notification every time a new video is posted. Bye for now.